Good evening, people, and welcome to the second meetup of 2021 of OpenValue. I'm your host, Paco. We at OpenValue like to share knowledge and do so about once a month with our meetups, now online and hopefully in the future again in person. Tonight we have two talks for you. Paco van Beckhoven will start on about mutation testing, and later tonight we have Brian Vermeer teaching us some tips and tricks on how to secure our Docker containers. Between the two talks, we have a small break of about 10 minutes. If you have any questions for speakers, please put them in the YouTube chat and I'll ask them on your behalf. And first up is my friend, my colleague, the cool-headed Paco. Paco, go ahead, the floor is all yours.
Thank you, Wouter. Welcome, everybody. Tonight, actually, I'm going to talk to you about mutation testing. And I know this is going to be a bit inconvenient because I don't really have a live audience, so I cannot do a show of hands. So I'm gonna try. I can see the chat here. So the question is actually who here knows what mutation testing is. So if you know what it is, just a small hand or I don't know, whatever signal that you're live in the chat. And at least I know a bit what the start audience is. And I know there's a small delay, but I think, oh, well, no. I guess that doesn't work, but that's okay. My name is Paco van Beckhoven. Oh, there, they're finally coming in. Sorry, there's a delay. But good, then at least there's some people who already have some knowledge, and I hope I can teach you a bit more. Again, my name is Paco van Beckhoven. I work as a software engineer for OpenValue, and also as a consultant, and currently I'm working on the conversion of AS400/mainframe code to Java. But besides that, I'm here to talk to you about mutation testing mostly. The reason why I chose this topic is I got started with this topic back when I was doing my master's. I was learning about test effectiveness, and I also wrote my thesis about that. And I noticed because I was already working at the time as well that a lot of people didn't know what mutation testing is. And that's what my goal of this presentation is to introduce you to this topic. And I want to start first with a small story about quality, because testing is, of course, also about quality. And it's about back when I was doing my graduation internship some long time ago, and I was given the task to improve and further develop the traffic-related Android application. And I started to do everything according to the textbook, everything we learned. You start making class diagrams and code cover. You increase code coverage, refactor for testability, and I even started adding frameworks for dependency injection and cool testing frameworks, where you could even simulate your car driving a certain route and see if certain alerts would pop up. It was all super nice, and I wrote this very nice graduation report telling how great it was that I improved the software quality over and over. But the whole problem was, and that also cost me a point on my grade, is that I never actually defined what software quality was. I just kept telling it's about quality. And to make up for those past mistakes, I want to start with a definition of what software quality is. And this is one by IEEE, which I thought was quite nice. And it defines it as the degree to which a system, component, or process meets specified requirements, which you could summarize as how well did you implement requirements. Now that is still a bit vague. And that luckily there's also a ISO model for this, which helps us structure these requirements. And as you can see, it's cut up in 8 different categories. And each category is actually a different vision of software quality. And what I noticed back then was when I was talking about software quality, I wasn't really talking about software quality as a whole. I was actually just looking at the maintainability aspect. That was my current scope. The bubble I was in was all about writing maintainable code. And the interesting part about this diagram is also that it's good to know that there are so many different perspectives of code quality. And even though you're talking about two completely different things, you're all working on the same goal, which is to write better software. And that was just a small thing I wanted to add because we're going to talk about testing and quality. But for now, I'm just going to keep it at testing. And to be more specific, we're going to talk about automated unit tests. And why do we write these tests? I think the most important reason for me is you write these tests to make maintenance easier. As soon as you build something, or maybe you start refactoring things, adding new features, you want to know that you didn't break the existing functionality. That's, I think, the best feature of why we have tests is to make sure to be confident about the change we make without breaking the whole application. But there are more reasons that why you should be writing tests. And one of the other features, for example, could be that tests actually also serve a bit as documentation. They can help you understand the domain sometimes. They can see how, already explain you how the application should behave. And there's a specific example I wanted to add here is that back one of my first assignments, we were building a microservice that was returning warehouses. And this specific service returned warehouses that were both deleted and that were not deleted. But the tests only expressed or were only including non-deleted, so existing warehouses. And then at one point, some developer came also on the project, noticed this, and then started thinking, wait, why are we returning deleted warehouse? That sounds really weird. I don't see reason why we should. So let's change that. Let's fix it. So I think this is a bug I found. And by then, of course, everybody forgot that this was intended. We implemented it. It got shipped. And then I think within an hour, we already got complaints that stuff was broken. And here, a simple test that also covered this scenario would have already been a very helpful indicator that this feature was there by intent. And also, and of course, the test is not the only place where this should have been. And I think there were a lot of other things that were missed in the process. But even the test here would have already been super helpful. And there's more. One of the things I like, this is not necessarily if you build your test for, sorry. When you write applications, usually you start with a sort of an explorative approach, where you first implement it, and maybe at the end you have these people that only write their tests right before they submit the pull request, because otherwise they know it's going to be declined anyway. If you were to write your tests all the way at the beginning, you can sort of skip this feedback cycle, or you can not skip it, you can make it a lot shorter. Because if you have to go through all these steps of deploying your application, maybe, and then figuring out there's a null pointer exception at the end, if you would have just written a unit test at the beginning, which you were going to write anyway, you get a lot faster feedback cycle. And I can go on. One of the other reasons, if the previous ones didn't convince you, is that a lot of us, at least at OpenValue, we're all consultants. And I know there are a lot more consultants out there. And what you see is that we often, we go from project to project. And by the time that stuff needs to be maintained, we're often gone. And the point is that you're not writing these tests for yourself. Maybe you think, oh, I've got this covered, I've got this manual test script here, and then I know how it works, and it's all fine. But as soon as you're gone, that's gone. And then the next person is there still trying to maintain, has no tests. It's really awful. So you don't do it for yourself, you also do it for the others, to the next person working on this project. And if this all usually is convincing enough, there's usually a software architect or a boss telling you that you should be writing tests or not. Anyway, we're going to end up with a lot of tests, at least that's what I hope. And the problem there is, because we, of course, are going to fix the problem here, is that as projects evolve and grow, the test code also evolves and grows further. But usually when refactoring, the test code doesn't get the same amount of love that the production code gets. What you often see then is that, for example, you end up with tests, especially if you have a project that's going on for quite some time, that actually are doing no more than a setup and a teardown. And these are just tests of which the functionality has moved to another class, but hey, this test looked like it was doing something, so we're just going to keep it. And that's also what you see in the monitoring and metrics. There are pretty much no metrics for tests except for one, and that's code coverage. And code coverage is can be expressed, as you can see here, the degree to which the source code of a program is executed when a particular test suite runs. And what you see is that code coverage is used as sort of a stopping criteria. Because so, okay, we have 100% code coverage on this class, or maybe 80, whatever it is for your project. That's good enough. We're going to continue. It's good. It's the definition of done. We can now ship it. And that's true. But I first want to have a closer look at code coverage, because there are different ways to measure it, and each different metric actually kind of already helps you write better tests. Code coverage is quite nice. And I want to illustrate this with a simple submit method. It takes a proposal, a number of open proposals, and a deadline. And as soon if you exceed the number of open proposals, allowed number of open proposals, if you have more than 3, or if the deadline has exceeded, you're not allowed to submit, you get an error, and otherwise you get success. Now, if we're going to start with the most simple coverage metric, that would be method coverage. And if we want to get 100% method coverage, all we have to do is write one test. The test here is a submit, call submit with a random proposal. There are no open proposals, so that's good. And the deadline is somewhere in the future. The moment we're the deadline is somewhere in the future. So that sounds good. We now have 100% method coverage. We can also go a step further. There's something called statement coverage, which is, and Jacoco sometimes calls it instruction coverage, in which you measure the amount of bytecode instructions that were executed. And as you can see, we are now missing a test case because the negative scenario in which we get an error hasn't been tested. So we need to add another test. And in this scenario, we exceed the number of open proposals, so it's now 5, and that would mean an error, and now we have 100% statement coverage again. And we can go another step further, which is through condition coverage. And this is all of the previous, plus that each Boolean sub-expression should be evaluated to both true and false. And so the number of open proposals, we tested both scenarios, but we didn't actually properly test the deadline check. We only know that it returns false. We don't know if it would ever return true. So we had another test, one with a deadline in the past. So this should also fail. Now you see we have 100% condition coverage. It must be great. And that's also one of the advantages. The main advantage of code coverage is it's really easy to use. It's cheap in terms of performance. You just run your tests, and at the end you can have a report that contains all your logic. It will show you what you didn't test, which is already really helpful, and also that all the tests you executed at least didn't crash. But code coverage can also be misleading in the terms that, yes, sure, you covered the code with your tests, but that doesn't say anything about the quality of the tests themselves. Maybe these tests were just empty tests, or not empty, but there were no assertions. For example, here, I have a test that just calls the proposal service, and the only guarantee this test gives me, and the code coverage that is related to it, is that it didn't crash, but it doesn't tell me anything about whether it was returning true or false, or what was expected behavior. And that's the issue with code coverage. It does not really give a lot of guarantees on the quality of the tests. And this is where the interesting part starts. And this is, you can measure the effectiveness of your tests. And you can do that, well, that's basically testing the test. And you can see this as how well are your tests able to detect bugs. And there are ways to do this. You could, for example, at the end of the day, just start making random changes to your code base and see if your tests fail, but this is quite some work and usually not reproducible. So that's not really optimal. Luckily, and there we are. This is where mutation testing is for. With mutation testing, that's a technique in which you simulate bugs in the form of typical programming errors in an automated manner. So we have there, it's reproducible. You have sort of bugs, and we can run this whenever we want. And mutation testing consists of 2 steps. The first step is generating mutants, and mutants are just a small change to the original production code. If you look at and these mutants are generated by mutators, and each mutator does a specific kind of change. For example, here we have a method at the top. That's the original method. We check whether somebody's allowed to apply for a driving license. And a mutator would invert the conditional logic, which is basically simulating a bug. And it can, of course, mutate this piece of code many times in different ways. So we can already generate 4 mutants, because we can also change the conditional boundaries, or which can just always return true or always return false, all kinds of bugs in which you hope that your tests should be able to pick them up. And it's not just Boolean logic. There's also, for the mathematical logic, a plus becomes a minus and the other way around, multiplication and division, and there's been for the modulo operator, which can be replaced by, I think it was the multiplication. And then there's also another type of mutator that removes any void setting, because of course a mutated piece of code should still compile, so you cannot take out method invocations that actually return something or have an impact on the code flow, but you can remove the void statements. In this case, we just remove it and see if the verifications will pick it up. And at the end of step 1, if all the mutators have done their work, you have a lot of mutants. And for each mutant, you're going to run the test suite. And if the test suite fails, or if there's one test that fails, that's great. That means that your bug has been detected. So if somebody would make this mistake, your test would save you. On the other hand, if your test would pass, that means that your mutant went undetected. And that's usually an indication that you either need more tests or that you need to add more assertions to your tests. And now this is the theoretical part. So let's have a look at the tools, because mutation testing isn't new. It's already there for quite some time. I think it was in papers around 30, 40 years ago, and it already entered the Java world at the beginning of 2000. These tools were, I think, released somewhere between 2001 and 2005, Jester, Jumbo, and Java. And it was actually quite nice, but these weren't really that popular. And one of the main issues my explanation is that these were mostly made for academical purposes. And what I mean with that, because without research, we wouldn't even have these tools. So it's a good thing, but often the use case, and I noticed this when I was writing my thesis, is that it's okay that if a setup of a project maybe takes a whole day, and it's okay if it runs for a whole day, because once you have your results, you can spend the rest of the time analyzing those results and writing about it. So you maybe do this 3 or 4 times in half a year. But for us as a developer, of course, it's extremely impractical, because if you have to wait a day every time or have to spend half a day setting it up, it's really inconvenient. And these tools, of course, most of them were not really actively maintained. I think maybe Java, but the rest doesn't support anything above Java 6. So it's practical, but, and of course, that's why I'm still talking about it. In 2011, PIT or PyTest was introduced. It was created by Henry Coles, and he took a different approach. And this is already where you saw that he did quite some things really well. The first step, but that was actually also present in some of the other tools, is doing the mutations on bytecode level. It's already, if you mutate on bytecode level, you at least get the compilation step for each mutant you have. That already saves quite some time. And another really great improvement was optimizing for coverage. So before you start running the tests on the mutants, you first do a dry run of your regular test suite. And for each test, you measure which code it covers. So that if you have a mutant, which only generates 1 line, or which only mutates 1 line, you know which of these tests are covering this 1 line. So you don't have to run all 1,000 tests. You only have to run maybe those 5 that actually also hit that line. That really saves a tremendous amount of time. And another advantage were, of course, the ease to use, and that's where you notice that it was also a bit more made by developers for developers. It supported, I think it still supports up to the latest Java versions, all kinds of frameworks, testing frameworks for Unit 4, Unit 5, I think TestNG, even older versions. So that's really nice, and it's actively being maintained and supported. And what I also really like about it is that there's even a collaboration between the more academic world and the practical world, in terms that from academics, you see that new mutators are being added, and they are also, Python is also actively being used in research about test effectiveness. So that's really nice. And as I said, it's really easy to use, depending, of course, a bit on your project, but it would be as straightforward as just adding the plugin and running the Maven goal. And that's also what I want to demonstrate to you. So here is the project. Let's increase the font a bit. Let's get rid of distractions. What you see here is the proposal service that we also had in the slides. It is a submit method, takes a proposal, number of over proposals, and a deadline, does the checks, returns failure or success. And this file is present twice in the project. I have a proposal service and a proposal service 2, which are identical. As you can see here, this is a div, only the name is different. The reason I have 2 is because I have 2 different test cases, and I want to illustrate, this is just to illustrate how to, the difference between mutation coverage and code test coverage. So we have 2 tests. We have the proposal service tests, and they have 3 tests, which are also the same test scenarios we used in the slides. And they have assertions around them. You can see them. It's not that relevant, some slight differences. And then there's proposal service 2, which has the worst kind of test. The tests that don't have any assertions and are just there to boost the code coverage. So that's the whole project. And then we have a POM file which contains the Maven plugin. And in my project, I use JUnit 5. And to get Python to work with JUnit 5, you need to add the extra plugin. If you use JUnit 4, you don't need it. And what I also did is I excluded the model just to keep the report cleaner for the sake of this demo. And then this project also has Jacoco in there for the code coverage. So I'm going to run the Maven. Right. Of course, I didn't memorize it, so there it is. I'm going to run a mutation test. This will run. And one of the interesting parts that I also forgot to mention is that I mentioned that at the start of what Python does is it first does a dry run where it measures the code coverage of each individual test. It also measures the execution time of each individual test, because if you start mutating Boolean expressions that are part of a while loop, there's a very, very large chance, there's a good chance that your project will end up with infinite loops. And what PyTest does, it watches how long the test is executed, and as soon as it exceeds 1.5 the original execution time, the test is killed. And this is actually configurable, so you can make it shorter or longer. But it's a really nice feature, because otherwise it would be a bit infeasible having to wait on all these infinite loops all the time. Okay, the project is the build passed, so we can have a look. There's now in the target directory, we have the code coverage report. So let's see how that looks. There we are. What you see here is that both the proposal service, there's the mouse again, and the proposal service 2 have 100% coverage, the structure coverage, all the coverage you can imagine. See that here as well. They're all there. Now let's have a look at the mutation test report. The first thing you notice that it's not that different from the other report. Here we have, for the proposed service, you already see some differences. There's something about test train, the mutation coverage, and there's also still the code coverage. If we go deeper, then you notice that, again, the code coverage for proposal service 1 and 2 is 100%, but there's a different mutation coverage. If you go in there, it's similar. As with code coverage, you can see the line. I'm not sure if that good visible, but the light green means it's covered. Slightly darker green, it means also that all the mutants on that line have been killed. Red means the mutants were not killed. You can see here the negated conditionals, so inversing the number of proposals check or inversing the deadline check, those two were detected because these scenarios you covered. But the scenario that we didn't cover was the edge case, the conditional boundary. So what we were missing is a scenario in which we test with exactly 3 open proposals and see if it would still break. And these edge cases are often also really important to test because, for example, when you have a Boolean conditional expression, so maybe you have a larger than, so if A is larger than B, and at some point you decide that it's a good idea to invert this logic, what you sometimes see is that people then think, okay, then we just invert the sign, we make A larger than B, we turn it into B less than A. No, sorry, A less than B, because there's somewhere explanation. The point is that usually the equal sign is forgotten, which is exactly the edge case, which is why it's really important to also keep testing these edge cases, because these are one of the often missed ones. And the other mutant that wasn't killed was the call to the notification service, which is the removing the void statement. And that's correct, because I did not do anything with mocks or verification to see if these were invoked. The other mutants that were killed were just replacing null instead of a result. And the same here as well. So here just always returns null and see if the test would pick that up. That kind of summarizes how a mutation testing report looks and how it could help you. Let's go back to the slides. Of course, this was a simple, tiny project. The reality with larger projects is that it's going to be really slow when you start. Mutation testing still is very expensive, and you can see running the amount of tests. If your test suite alone already takes maybe 10 to 15 minutes, then running mutation testing would be a 10, 100, or 1,000-fold of that, which might even be taking forever. At least that's how it would feel. And of course, luckily, there's something we can do about this. The important thing is when you start mutation testing in your project is to really start small, limited to only a small set of class, or maybe even just one class, and the test for that one class, so that you're absolutely sure that the mutation testing tool is going to run, we're going to get results, and from there on you can start expanding. And the interesting part about PyTest is by default, of course, single-threaded. I would definitely advise to use as much threads as your computer has cores for it, because it really speeds up the process. That does mean that you have to do some concessions, but it's usually worth the speed advantage. And from there on, you can start increasing the number of classes, and then you can do other tweaks. And the first one where you can look at is reducing the number of tests you run. If you have a big project, one of the things we had in that earlier mentioned project about warehouses is that we also had acceptance tests that were actually Java tests. They would just start up the whole Spring Boot application, and they would do REST calls against it. These acceptance tests, of course, cover almost your entire code base. That's usually what you have. You go over the entire flow, which also means that these usually also slow tests are covering a lot. Well, by the fact that they cover a lot of code, it means that the test is also executed for a lot of mutants. And apart from the discussion on whether exception tests are actually proper unit tests, that would typically be one that you would leave out. And the same would be for database tests, which you often also don't really, or mutations don't always add that much value, for example, when you're testing queries. Or if you just have really slow tests, then you could make the choice, okay, I may get more negative or may get more undetected mutants in my report, but at least the execution time is maybe cut by half an hour. So these are choices you make. And the less tests you have, less time the better. And the same also goes the other way around. You can have less tests and you can also have less mutants, because there are always things that you might not need to mutate. And the most obvious example is don't do it for generated code, but there are also other scenarios. I'm not sure if anybody here has ever written a PDF generator in Java that does generates a dynamic invoice with different lines. That would be a lot of pluses, minuses, multiplications, offsets, and margins that are constantly being multiplied. When I did this for the first project, I think it managed to generate almost 1,000 mutants just for my PDF generator class, which means it would also execute the tests for that at least 1,000 times. And because I knew the tests and they were pretty good and pretty thorough, usually also because you're doing PDF, maybe you're checking it on even a byte level that your PDF is still intact, I decided to leave those out. Again, this can speed it up by 5-10 minutes. That's a good one. And also here for database logic, and also if you have anything related to complex threading stuff, which you also know, okay, these tests are which are often already hard to test. You might not want to generate mutants for those because it's only going to be painful. Then there's another feature, especially if you're doing this on larger projects and you really, really want to continue with mutation testing. There's an experimental feature in which they use what they call incremental analysis. So they store the results of the last analysis, then they do a diff in which lines of code have been changed. They know for which lines they have to regenerate mutants, and they also know which tests were affected and were not affected. So you only have to run a really small subset of your mutation of the tests to see whether anything changed or what the impact on the result was. And that's a bit about improving the speed. And then there's also some nice details about, for example, keeping your reports clean. And one of the things that you have usually a lot in your code is logging. And logging also may have some minuses and pluses, apart from the fact that they're all void statements, which can be removed. These are typically the mutants that you will not detect because you don't test whether things are logged. By default, PyTest actually already excludes doesn't generate mutants for all calls to the major logging frameworks, but you might want to extend this list with, for example, a custom logging framework, maybe some metrics that you have, some metric logic or extraction, which you do not deem relevant enough for unit tests. That at least, again, saves you quite some noise in your reports. Then the next step, which you can also tweak, that's the last part, are the actual mutators. This is a list, I think, of the current set of available mutators for PyTest. And only a small subset is actually used by default. This is the set of mutators that were deemed the most stable and the harder generating the mutants would be the hardest to detect. Some of these mutators on the right are similar, and some of these are rather complex. You can start adding more mutators. You can just expect there are explanations of what each of them does. But do note that the more mutators you add, the more mutants you're going to get, the slower your test case would be. And another thing of mostly of these experimental mutators is there is a risk that you might run into something called equivalent mutants. And the problem with equivalent mutants is that they are undetectable. What you see on the left is a while loop that breaks increments I in each iteration. It breaks if I is equal to max. If I would change I is equal to max into I on the right side is larger than max, it would still break as soon as I hits max is equal to max. So the larger than mutation is functionally not any different from the original. It cannot be detected. So you have a mutant that will be there and you can never detect it. And that's also not automatically detectable at this point. So keep that in mind when going to the reports. Well, adding mutations to your continuous integration tools is pretty straightforward. You just run the Maven goal, and there's also plugins available for most integration tools. And just like I think Coco, you can just tweak or configure your PyTest to break your pipeline if it's below a certain threshold. And I would definitely advise running it as part of the nightly because it's not going to be fast. And the last thing to discuss is when you should actually start considering mutation testing, because mutation testing is not a silver bullet. It's computationally quite expensive, and these reports, having to go through them can also be quite time consuming. So these are the most obvious questions which actually apply to almost nobody here, I think. At least I don't know a lot of people that work on projects that involve lives or a lot of money. But these are, of course, projects with really high quality requirements. And then at that point, you want to do everything that's possible to prevent any form of bugs. And mutation testing is a tool that might help you to cover any possible scenario there. The more realistic questions are, for example, are you using code coverage? And because if you're not even using code coverage, then mutation testing is not going to help you any more than code coverage is going to do, because the first thing you're probably going to need is to write more tests and actually monitor if you have sufficient tests. Then you can start looking if these tests actually also make sense. And if you already have code coverage, then is it also something that's really important within your company? For example, are you making business decisions on it? Or if the code coverage is below 80%, somebody is going to have a bad session with some architect somewhere. That might be the point where you also might want to start using mutation tests to actually see how good these tests actually are. What's the value of this code coverage score? Because maybe it's just empty assertionless tests. Another example here is the cost of fixing a bug. I have two projects I worked on, which were kind of the opposite of each other. The first project I worked on was for a company that was building enterprise-like software, and this was running on-premise at the customer, usually governments that only have really, really slow release cycles and also release windows in which you're allowed to upgrade your software. If software would have a bug, that would be horrible, because you would have to even go to customers and try to get a fix in there, which usually results into having to use a workaround for half a year until you can finally get the bug fix in there. And that's, again, a place where fixing a bug is really expensive, so you want to prevent them as much as you can. On the other hand, we have the more startup-like projects where we're mostly working with a fixed fast mentality. We could just deploy it to production within a few clicks, and within a minute, I think it was already live. At that point, it was okay that there was a bug. We also were monitoring that actively. We had a lot of support, and we could just fix it fast. Then that's usually even faster than having to go through all these reports. So there's a choice you make, and it also kind of determines on how much you want to invest in more quality. And I think the last thing is also to make sure that you have your team on it. So if your whole team thinks mutation testing is not that interesting or it's too much work, you're probably might be wasting a lot of computational power, because no one else is going to look at it, and probably as soon as you're gone, it's also gone. What you can do in that scenario is try to set it up locally. That's also what I would definitely advise before starting. Just start locally, set it up there, just run it once, get a full report, maybe wait a day for it, let it run for a day, but then you have a report, and that already helps you to kind of evaluate what the current state of your test base is. And you don't have to run it every day or every hour. You can run it maybe once a week and just see where are the blind spots. We have tests here that have high coverage, but they don't kill any mutants. Those are usually the flags you want to look for, because that means it's covered without any proper assertions. And that's actually already it. So to summarize, code coverage is really about how much of the code is tested. And then mutation testing is in addition to that, which would probably tell you more about how proper the code has been tested. And once you start using it, start small, elaborate, expand, and keep tweaking for performance. And that's it. These are some links to mutation testing frameworks for other languages. And if you have any questions, feedback, suggestions, you can also reach out to me on Twitter. Thanks.
Awesome. Thank you so much, Paco. If you have any questions for Paco, please put them in the YouTube chat, and I'll ask them on your behalf. I have a couple of questions on my own, so I'll start with those. So, would it be possible to introduce mutation testing in an already existing project? And if so, what are your challenges?
I think even that would be the best case to start mutation testing is within an existing project. If your project is new, then you're spending more time on building new things than you're going to be spending on reports, whether your tests were already 100%. So that's what you see for greenfield projects. And I think your challenges would be that you already have a lot of tests and it's going to be real slow. So as I mentioned before, you're really going to have to either make some choices, cut out some tests, or accept the fact that it's going to take a lot of time. And also maybe there is something that clashes with the mutation testing framework. At that point, that's the reason also why you would start slow and slowly start adding packages to see if it still works and if it's working good. And it was one thing I forgot to mention. All the concepts I explained, which were mostly about PyTest, also apply to the other mutation testing frameworks. The ideas of the ways you tweak it, it's pretty broadly usable, and it will also help you with, for example, Striker. Sorry.
Cool. And so you are now using PIT or PyTest. Is that also usable for other languages, something JVM-like languages like Kotlin?
Yeah, that's a good question. I'm not really sure about it actually for PyTest. I thought there was, as you can see here, the Striker does work for Scala, which is of course another JVM language. I'm not sure about the Kotlin experience. Kotlin support. I think I've seen something about it, but I would have to look into it. It's a good question though.
I don't think we have a lot of questions from the audience. There was one question about IDE integration, but Ton already answered that there is a PIT test plugin for IntelliJ. So I'll stop with. I'll continue with one more question. So you also were talking about excluding parts of your application to improve the scanning time. Is there like a curated list available, or is there something that you recommend to start with? Basically, a same default to start with.
No, I don't think there's a curated list or any list for it. In the example, I think I used a utils package because those are usually the code that's you want the most straightforward code of which you know there's no weird stuff going on that might break, maybe threading, maybe tests that might break because they cannot be run in parallel, or something that could be more exotic. It usually does work, but just start with the most straightforward, simple part, which are usually utilities and their tests, which don't do that exotic stuff.
Okay, thank you so much. I think we'll then go to the break. It's now 43, so let's call it 55. We'll be back at 55 with Brian Vermeer talking about how to secure our Docker containers and make them secure. See you in a bit, get something to drink, and we'll continue with the next talk. Bye.
Bye.
Okay, welcome back from the break. Let's continue straight on with our next speaker, with his talk, 5 tips to create a secure Docker container for Java developers. He's a software engineer and developer for Sneak. You've seen him speak at meetups and conferences around the world, and he's single-handedly making the world a more safe and secure place. Ladies and gentlemen, Brian Vermeer.
Wow, that's quite an introduction, Wouter. Thanks. Single-handedly making the world a better place. That's well, please take that weight out of my shoulder, because that chip on my shoulder is way too heavy. But hey, welcome. I'm enjoying my coffee. Hope you have some. And we are going to talk about security and about container security in this case, but specifically for Java developers. So, but we have to talk about something first, because let's talk about this term, container. What is a container? And we also always want to grasp software concepts and compare them to real world things, right? So if we look at container, we can look at containers like this. This is the well-known soda can or the beer can. We can look at a container like this one, which might be the airtight container where you put your food in to let it, well, keep it crisp or stay let the flavors in, make sure that it's good and well preserved. Or as a more larger concept, we love to look at containers like this, the shipping container that you put on a boat or a ship, on a train or on a truck. And all these things are basically receptacles for holding goods or portable compartments which well, objects or freight is placed. And all of these three things have one thing in common. They are a protective barrier against the outside world. They try to minimize the influence from the outside world to the containment. So, well, might be obvious, but the soda container is there to keep the flavors in, and that shipping container is there that if you transport goods, that they will stay intact. However, it is very, very important that you pick the right container. And again, for a real world thing, that seems logical, seems obvious. However, if we transport that concept to software, are we doing that? Or are we putting our beer without the container in a shipping container, like the one below? That doesn't help. So pick the right container is one thing. Secondly, this container is some sort of security barrier for the outside world, because we don't want the outside world to get in. However, there is a concept that people think that if we put software in a container, like we do here, say we have this container and I put my Java program in, that by putting it in the container, by default, it is safe, because we had that analogy of that real life container. Unfortunately, this is not true. And that's because of a simple concept. We have two-way traffic. We need to get in and outside that container. If that container is there on its place and we don't do anything with it, perfectly fine. Then you're at the right point. However, we need to interact with it, like make sure that we can have data from a user or from a database, send data out, make sure that, well, basically it's a container with holes in it, but specific holes. So putting a Java application inside a Docker container, because I will focus on Docker this time, doesn't make it safe by default. You have to do something. It is another layer of abstraction, but you need to take care of that. Hold that thought. Hi, for those who don't know me, and probably a lot of you, that's no problem. My name is Brian, and you see this is a picture pre-Corona time. You see the difference, right? Hopefully hairdressers will actually open up at the end of the week or beginning of next week, and I will be more like this on the picture. However, I do a bunch of stuff in the community, and I'm a developer advocate for Sneak, and well, that means I'm developing and I'm advocating. I do some stuff for the virtual jug, and I see this as an old slide because until last week, I was a co-leader of the Utrecht jug, but I recently announced to the members that I will, well, give up my place in the board over there because something happened last week. I was announced as the board member of the NL jug, one of the board members, one of the technical board members. So you will be seeing me in another position if you are an NL jug member. However, this is all fun and stuff. This is me. You're not here for me. You're here about the subject, about containers. And we're going to talk about Docker containers because Docker containers, there are a lot of them and people are using them quite often. For instance, 1 billion weekly downloads of containers, and that was somewhere in 2020. I don't know what the current number is. Regardless, it means there are a lot of Docker containers. And what we do with Docker containers is we pick a Docker container from Docker Hub and we build our stuff on top of that. Hold that thought again, because I will give you 5 tips not to fail your security. First one, I already said that we pick a container from Docker Hub. That's in many cases what we do. But we have to make sure that we choose the right Docker base image for your Java application. Not any Docker image is good enough. Again, you don't want to store your soda without the can in a large shipping container. Doesn't make sense. Same analogy holds for software or for your Java Docker containers. For instance, from Ubuntu, this is how we start. Like we take an image from an operating system in most cases. And then, well, what we did somewhere in 2019, I did a research on Docker containers and I downloaded the 10 top Docker containers, the 10 free Docker containers, top 10 free Docker containers from Docker Hub. And we scanned them with our stuff at Sneak to see if there are vulnerabilities in it. Long story short, all 10 had vulnerabilities. And that can be from 500 something to 31. And you saw already in the previous thing, I said from Ubuntu. I didn't specify any tag or something like that. That's what I did here as well. So by default, we take the latest container. That means by default, I have no clue what's happening there. In this case, the default container for Node, for instance, depends on a very large Debian distribution. And think about it. Is that something that we need for a Java application? Do we need a full-blown application or a full-blown operating system for our Docker containers? Probably not. However, in many cases, and if we look at tutorials on Stack Overflow or whatever, we see these kind of things. And if we look closer at the containers, actually the open source or the operating system containers, we see there is a large difference between which operating system I use. So if I use a Debian-based operating system or a Debian Stretch Slim based container, that already gives me a lot less vulnerabilities. And these vulnerabilities are there in the binaries that ship with that container. So you might not directly use them, but you're not sure, because it might be that the library in your application uses them, or that through different holes you can do that. If you think about security, it's not only like, this will not harm me because I never call this. It's always, well, somebody once told me, security is like Swiss cheese. There are holes everywhere. So if you go in one hole and you can connect that to another hole and to another hole and to another, then it might be vulnerable. It's like an onion. Make sure that every layer is secure. So why do you want to hold binaries that you don't use or are not useful for your application or for the functionality that you want to encapsulate? If we take a more Java approach and we look at the adopt OpenJDK for OpenJDK 11 images on Docker Hub, and I scanned them, I think a couple of months ago, and you see that there's a difference as well. The latest by default is an Ubuntu version that has 25 vulnerabilities. But if I specifically take the Debian one, so the JDK binaries are still the same, but based on another operating system, I bring in a bunch of more binaries. Ends up in a lot more vulnerabilities. For Alpine at that point, it was 0, because at that point, there were no known vulnerabilities for the Alpine version. I scanned them just before this, just before this meeting, and let me show you the current results. So not like, yeah, you did this once and now it's all better. If I'm looking at, let me just recapture my screen. This one over here was the Debian package. You see that in the bottom, you see that there was the original command. I did a Docker sneak container test on the OpenJDK Debian, and we see that there are 80 vulnerabilities found, and all these 80 vulnerabilities are somewhere in this Debian thing. So that means that if you take a Maven package or a Maven-based image that is based on Debian, because it is a cascading thing, you will have all these vulnerabilities for free. Taking the same OpenJDK version, but the latest one, which is based on Ubuntu, already gives you 23. So picking your base image is like building the foundation for your home, for a real life structure. It has to be solid. So from that fashion, we know that we need to investigate where we base our stuff upon. But then we only need to use what we actually need. And that sounds obvious again. But let's go to a very naive way of building a Docker image. Like this. If you look at the majority of the blog posts, like how to create a Spring Boot application with Docker, you find something like this. And what I do over here is quite obvious. I'm using a OpenJDK 11 Maven 3 image, so that has OpenJDK 11 and Maven 3 already streamlined in it, and I built my stuff on top of that. I create a directory, I copy all my source files over there, make sure that there's a work directory, and I call Maven package to do this. Let's just do this. I have the Docker file over here, as you can see, basically the same Docker file, and let's just do this. So I'm Docker building this image with this is the Docker build -t JCW, which stands for Java Code Workshop, which I created a bunch of time ago, just as an example. And I gave it a tag 1. So let's build this one. Now let's see how it works. And I already have the images that is based upon, so it doesn't need to take a lot of time. But let's go back to the image definition first, because now it's downloading all sorts of things from Maven. But if we look at this image declaration, we see a few things that are interesting to us. OpenJDK, Maven. And then we use Maven to run your Spring Boot application. So basically what you do is you download the whole JDK, you put your code in it, you use Maven to compile and build the code to an executable, or well, in this case, an executable jar, and you use Maven again to run it. But if we look at what we actually need in production, is that what we need? We don't, because in the old days where we were working with IBM WebSphere and that kind of stuff, we build WAR files. In this case, we only need the jar file. So you only need the product of what you created. That also means that you don't need the whole JDK. You don't need the whole JDK. You only need a Java runtime environment. And it means that the JDK ships with a Java runtime environment, obviously, but you don't need the whole JDK. You obviously don't need Maven. Moreover, if you do this, there is a chance that if somebody can get into your container, the code is there, the build environment is there, that somebody can seamlessly change some things, maybe restart the container without you even knowing it. And that is not what you want, right? So looking at this part and looking back at the application over here, we created the container, cool. So let's just look at it, how big it is. Docker image ls. And we see that JCW1 is large. It's like 800 something, almost 900 megabytes large. And that's not what we do. That's not what we want. That's not what we want to put in production if we think about production-based images. What do we need? Well, what we can do is we can build on our local machine and then put it in an image, or we can use the so-called multi-layer, multi-stage builds in Docker to do this. So I can do something like this. And well, I prepared it, so let's not do this. Let's skip this one. And I already prepared it over here, the second part. So what I'm doing here is I am using the first image to build my stuff, which is perfectly fine. But then I only use the product to copy that over to a second image that I'm creating that only contains a very small Java runtime environment based on an Alpine image of OpenJDK. So an OpenJDK Alpine, which is already small, Java runtime image. I only have the jar, and I simply call a Java minus jar to create the stuff. If I do this, and let's make this number 2, and let's build this one, we will see that obviously this image is a large, it's already there, successfully tagged. That's cool. I probably did something wrong. Well, never mind. Let's go back to the slides. Because, hey, if everything else fails, this one 800 something, you see already that it was larger than that, but your build image doesn't need to be your production image. If you split the two, as I just showed you, in this case that we changed it, and the naming is a little bit different, but we see that it's smaller than this. And the most important part is because it's smaller, it doesn't contain all the things that we do not need, which, well, clean desk policy, kind of. However, if you need to put other things in your build image and you don't want to do, you want to do this in a Docker file, let's keep that as a certainty. If you want to do everything in a Docker file, like building and producing the production image, we don't want to have things in like passwords or secrets or that. And if you do a Docker history on a certain image, you will see what happened basically. And you see that if you do that on your production image and you put in passwords or you punch in secrets, you will see that they are visible in these caching layers. However, if you do this in a multi-stage build, for instance, like this, say my repo name uses a username and a password like this. Hopefully you don't, but just for the sake of argument, if I do this in my build image, it will get thrown away eventually because only the production image will stay there. So this is a good way to separate these two concerns. Let's go to the next one, which is the least privilege principle. Well, the least privileged user in this case. Because think about it. You're in a hospital and something is wrong with you. Do you want every single person in that hospital, like every nurse, every doctor, even a janitor, that he or she knows what is wrong with you? Probably not. Same holds for software. What do we need? And only the stuff that we need to do, we are allowed to do. Nothing more, nothing less. The problem is only like if we look at images like we did before over here, that same multi-stage image, it looks fine, right? Only I'm not actually creating a specific user for this. If I'm not creating a specific user for a Docker container, by default, Docker will run your stuff as a root user, which may be fine for a very small container because we already stripped all the things off, but that's not what you want. You shouldn't be doing that. You have to make sure that if we want that, and we're talking about that lower part, so that production image, we actually want to create a user that is only can specifically do what needs to be done. So let's do this. The only thing that we have to do here is literally create a new user. Oh yeah, let me highlight the lines that are important. So what I'm doing here, and I'm using an Alpine image, so the terms and the commands are maybe a little bit different than are a little bit different than you usually do with Ubuntu or Debian, but it's basically the same because we create a group and we create basically a system user without shell access, and we bind that new user to that group. We make sure, in this case, I chose to make that user the owner of my project working directory. And don't forget that last yellow line, because that last yellow line makes sure that every command afterwards is called by that specific user. If I create a user, make it the owner, and not say user Brian Vermeer in this case, we will still run it as root. This also means that if you're using a base image that provides you already a specific user with less privileges, you need to call it. So make sure that you have a user that has, well, at least not the root privileges. So if something goes wrong, it's only in a bubble, which is a very hyped word now in these Corona days, right? Bubbles. Docker images and Java applications during development. I already showed you that I'm scanning my base image, but I can do basically the same with an image I created. Docker sneak container test image, and I'm using tools because, well, they're free, you can use them, but there are multiple tools you can use. The most important part is that you have to use them, because if we, and this is from the State of Open Source Security report that we published in 2019 and 2020, and basically had the same results. Like, when do you scan Docker images for operating system vulnerabilities? Half of them don't. Half of the people don't know that this is a thing. And it is a thing because, again, this is the foundation. It's not only the base image itself, but also the binaries that come with it that are your responsibility, because you don't just hand in the binary that's there, because now we are doing DevOps and we need to be cloud native. We bring in the whole Docker image and we're responsible for the whole shebang. So what I can do, and I also already showed you that I can do something like, hey, I pull the latest OpenJDK 11 version, and I'm using my sneak container test to give me an example like what's wrong with it. You will see it like here, like, hey, what vulnerabilities are there? And then you can decide, when you know which vulnerabilities there are, you can decide if you want to use this image or not. Maybe you want to create a specific image with just from the ground up and strip everything you like. Or you see that some vulnerabilities are there, like, okay, they are so not important to my use case, but then at least you make a conscious decision of what is going on. Moreover, if you've done this and you've done a great job by developing it and by scanning it and it's all cool, then you put it into production. But vulnerabilities will be found over time. So a good thing is to monitor these things. And we can do that the same by, instead of test, doing the second line to do a monitor. What it does, it takes a snapshot of that point in time and it will scan over time. And again, there are multiple tools to do this, but at least then you know, like, hey, this thing is in production. If something comes up, you know, and you're not in the dark. But next to that, we're talking about containers. There's something else in that container. That is your Java application. And this is the binary that is your Java application. And we already know this, right? Because this is the binary that I put in that airtight container in the first slide. But as you look at your application, you know that probably this small part is your code, because the rest is probably things like Spring Boot or Quarkus or whatever hype framework is nowadays popular. or whatever library you pull in. And that is for a good case because we do not want to do boilerplate stuff. However, we take great pride in our code. We do code reviews and we do pair programming and we do tests, we do mutation tests, and our code is excellent, maintainable, scalable, whateverable. But how about the rest? If we look at these, things, then for instance, if you look at Maven Central, and it's not so much the dependency that you pull in by using Maven or Gradle, but it's transitive. Just like pulling in the Docker container has a bunch of binaries, pulling in Spring Boot Starter brings you a whole shebang of other things. And I'm now saying Spring Boot because it's the most popular framework, but it's basically for any library, you should know what's going on. So what do you have in place for version management in that case? Do you have some review process in it? Or maybe you scan it. And what can go wrong in this case? Well, let me show you that. I have a small demo from a Spring Boot application in this case, and this is not the Spring Boot application I was looking for. Let me go to, I must have it somewhere. Here. This is a Spring Boot application. And the Spring Boot application is nothing really fancy. The Spring Boot application is a grocery list. And this grocery list, well, as you can see, and I will enlarge it so you actually can see what's going on. It has a bunch of groceries with a price. Not very interesting. Also, let me catch this and close this. Also, the items itself are not really important. It's just a simple podio with an ID, a name, and a cost, and some getters and setters. But I'm using Spring Boot 1 in this case, an old version of Spring Boot, and we all need to cope with legacy applications. And I'm using Spring Data with it, so I can extend the CRUD repository, which is fancy. So now I don't have to write all these CRUD info myself. I can do something like find by name and find all, and automatically it generates the actual stuff for, in this case, my database underneath it. What I'm doing as well is I have a REST repository resource, which is Spring Data REST, and it transforms my CRUD repository into a REST repository, into REST endpoints. And that's kind of cool because now I'm done with prototyping. I can work on my front end, right? And it all seems convenient. But let me just hope for the demo gods that they will actually run this stuff. Yes, go demo gods. Well, at least you can see this is not well prepared, or this is prepared but not videotaped. It is a real life thing. So let's go to, for instance, localhost 8080. And I can see that I have my hell browser. And what I can do here, I can do things like I go to item/1, and item/1 will give me, if my computer stops rambling, it will give me my first item in my grocery list, that beans for 50 cents. Cool. I can do all sort of things like you see that find by name. And if I do the name is beer, hey, this is now a REST endpoint. By doing this, it will give me the beer. Cool. So it works perfectly. My tests are running. I do mutation tests. I do every kind of test, every possible test, and it works fine. Because, hey, there's a big company behind this, this framework. Cool, right? It works. Don't touch it. Ship it. However, you already guessed it. There's a problem with it. And the problem is that if I'm going to my terminal, I will show you something. Let me show you the JSON. Well, let me show you the passwd by that case. So I'm going to copy paste this. Just 1 second, my bad, because my mouse is not working with me. Let me copy paste this URL. Do it over here. And what I'm doing here is I'm doing a curl patch request. And the content type is perfectly fine. It's JSON patch with some JSON in it. And this is the JSON. And the JSON is weird because what am I doing here? Well, I am utilizing the Spring expression language. In this case, if I do a patch request, I will get into an exceptional flow and I can utilize SPEL. And with the expression language in Spring, I am allowed to create new objects or call objects or do something, actually execute code. And what I'm doing here, I am getting the runtime and I'm executing something. In this case, I am calling the passwd file, as you can see here. But if I can call something that is there, I can also create files. I can might even delete files, or I can import a script and run that script later. And the fun thing is, I'm running it at localhost 8080 items 1. The one item, the first thing I showed you to give you the first item on my grocery list. And by doing this, you will see that in this case, it's my local machine, but I have access to my passwd file. The passwd file is available for a lot of people. But if I run this as root, like I showed you before in a container, I have access to the whole shebang. I have access to every executable in that Docker image. And if that executable can do something or something harmful, then it's interesting. Or even not so harmful, I can create an SSH tunnel to it or something like that. Problems with security are most of the time are cascading problems. Keep that in mind. So, okay, I am doing this and I need to scan my application. So if I'm scanning my application and I'm having my application over here, and I can do it either in my IDE or I can do it on the command line. Let's do it on the command line. I can do something like and again, I'm using my tools, but let's see what's going on. And this was the other application. This is not the vulnerable application, what's going on, but you will see already that I'm using an outdated Spring Boot version. I'm using 2.4.0. In this case, I have a problem with 2.4.0. There's a problem in Spring Data JPA and Spring Data REST in that application that I created my Docker container for. And I have to at least upgrade it to 2.4.1, which saves my problems. The other one over here, you see that I'm using the H2 database. It's a demo application and I did it on purpose. So I'm good with this one. So now if I just get rid of these problems and these cascading problems within my dependencies, and I'm using a Alpine Linux, for instance, base image, I'm quite secure. It's never 100% secure, but I'm aware of what's going on. Last thing number 5, build to rebuild. And that sounds, on one hand, that sounds weird, but also obvious. Say this is your Java application in your container. Well, most of the times, if you run a application in a container, you probably want to run different instances of it, right? Maybe on a cloud instance, maybe even elastically scaled. And most of the time, these things are containerized. So we have 3 instances of the same Java application running perfectly fine, harmoniously in production. And everything runs fine, and I have everything in place, including monitoring and logging and that kind of stuff. And now I found out that in pod 3, and I call it pod, but it can be instance 3 or whatever you name it, there is somebody malicious in it, a hacker. What is the first thing that I want to do? I know that it's exactly in pod 3 because for some reason I logged that and I monitored that and alarm bells go off. I want to blow that one up because then the immediate threat is gone. He might be able to do it again, but at least I'm sure that the active thing, I don't know how difficult it was, but he's gone. And what I want to do is I maybe want to spin up a new version. And a new version can be the same version, but you probably found out there is an issue somewhere, you fix the issue, and you want to be able to spin up a new version of it. And then take the second one down, spin up a new version, take the third one down, etc. But you have to be aware that just putting a Java application in a container needs to be container aware. And of course, we need to make sure that you're using the right Java version. As you probably all know from Java 10, the JVM is container aware, but that's not what I'm talking about. I'm talking about things like persistent data in your container, like a database or persistent logging or caches. These things are natural for a standalone application, but you shouldn't be doing that in a Docker container. A Docker container should be disposable. You should be able to throw them away as easy as you created them. So you have to get them out of these containers, or at least make sure that they're auto-regenerating. So if you have a cache in it, make sure that it is a self-healing cache, like, well, for instance, an in-memory data grid like Hazelcast, or name any other of these things. If you have a local copy of the database, make sure that it actually syncs, because if you blow that container up, all your persistency is gone. So you need to get it either out of the way or make sure that you auto-regenerate it. So it already starts from the architecture of your application that you need to be aware of this. And did you know that 44% after Docker image vulnerabilities can be fixed by a newer base image, just by not even the Java application, but just switching out the base image, everything is good. But what is more importantly is, how do we find out about these things? By if you already deployed a container. A lot of people don't. And that is, in my case, that is, in my instance, that is disturbing. It is a significant thing that if you are in production and we take care of our application, it's one, but that next layer, the Docker image, and then we have that next layer, which is your infrastructure as code. These are things that we need to take care of as well as full DevOps or full stack developers. Moreover, this one is interesting, is that 20% of Docker image vulnerabilities can be fixed by just rebuilding them. Not even changing a letter, but just rebuilding them. And that is because a lot of people use these kind of way to write images. And this is, of course, not Java, but it's like I'm using an Ubuntu latest image. And we already know that the latest image today might be different from the latest image next week because, well, people upgrade images. It might be based on newer insights. People fix vulnerabilities. People, well, you know what I mean. Same holds for binaries that you pull in by, for instance, apt or other package managers. Even though your Java application didn't change, but if you build your Docker image like this, and that's a choice. I'm not saying it's wrong or right. I prefer to do it, prefer to use not just the latest tag, but to prefer to use a hash for it so that I have the exact image. But then again, we need to make sure that even though the Java application didn't change at all, that our container also, like the base images, also have newer versions. So by updating these base images, if you look, for instance, the latest tag, if you're not changing your code whatsoever, but you just rebuild that Docker image, you will see that over time things will be fixed. So by putting it to production and not looking at it anymore, you're making a horrible mistake. However, if you're rebuilding it, I would suggest that you make sure that you use the no cache option in this case, because, well, things go wrong. I don't trust machines at all. And now I'm sure that Docker will not have a cache hit. Just saying. I will conclude with a small summary of this. And these are just 5 things. We have more. We have a lot more, but I only had half an hour. So first of all, choose the right base image. How do I need to build my foundation? And secondly, only pull in what you need. We don't need a JDK. Java runtime environment is enough for the production stuff. Never, ever, 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 ever run your container as root, even though you can be aware that you don't need to. And even though you can create a specific user for that, but I already explained that. Scan your apps and your images for during development, but also afterwards. Like when it's in production, keep scanning them, keep monitoring them, and build to rebuild. At any point in time, you should be able to demolish one of your containers and spin a new one up. If that is the case, then you already have a nice, proper, scalable architecture from a security point of view. If you want to know more about this, I recently created a 10 best practices for Java containers for my company Sneak, and 5 of these I just picked out and are over here. Other things I say, for instance, are, hey, you have to be aware that you use the correct Java image. maybe you shouldn't be using the Java command as process ID 0, but use, for instance, .init for it, etc., etc. This is the one pager, but you can read the whole blog on the URL below. Last, but certainly not least, every year we're doing a research to what the JVMC ecosystem is, and I recently created the next survey, and I want to ask you all, please go there and please fill in what your situation is. What JDK are you using? What Java version are you on? What is your favorite IDE? And you can choose more than one. So it's not like I have to choose between my two babies, IntelliJ or Eclipse. If you're using both, you're allowed to choose both this time. So we want to get an accurate image of what the Java ecosystem will be, so I can create a nice report out of that. That's it. Thank you. If you have any questions, you can always ping me on Twitter, and you probably have it in the YouTube chat already, but I didn't pay attention to that chat. Hopefully either Wouter or Bejan did. So I want to give them the word.
Awesome. Thank you, Brian, for your talk. Hopefully the world be a little bit more secure after your tips and tricks. We got a couple of questions from the audience. Nick Stolwijk starts off with Spring Boot now makes the images itself with build packs. Is that secure, or should we change something about that image also?
Yeah, that's a very good question. You have you can have the plugin from Spring Boot to create the Docker images, or you can use things like Jib to do that. For some people known, I won't say it's bad. I won't either say it's good. You have to be aware of what you're doing, because if you're using stuff blindly, you have no clue what's in it. So I did it last week or 2 weeks ago, honestly, and even in the build packs, there are vulnerabilities, because these build packs are also based on slimmed down versions of operating system, and you should be aware of what you're doing. Next of it, it's still a Docker image. Are you certain that, for instance, it's not using the root user? And you can do all these kind of things. So I'm not saying it's bad. It depends on what your situation is. If you use it, for instance, for internal testing or whatever, that's perfectly fine. But if you go to production, you have to make sure that all these other steps are also met. So are there binaries in there that you don't use? Or do you blindly trust Spring? That is a question up to you that only you can answer.
Fair enough. Another question by Nick Stolwijk. At one point, you were talking about that there might be some malicious activity in a Docker container. And he asks a question about that. With Hazelcast, the cache survives the container can already be compromised. Shouldn't you wipe the cache after a break-in?
Absolutely. You can. Again, it depends on what you. If the cache is compromised, definitely. If that is part of your thing, the cache could be wiped. It depends if there are things in it that he or she can write to it. If it's, for instance, a read-only access on that cache, it's not a big problem. Yes, the stuff is stolen. That's you can count on that. But if it's not manipulated, maybe not. So it depends on where you are. I know systems, I've worked on systems where we had different systems that can only write and some systems that can only read. So it probably depends on your situation again. I look like a consultant now, right? With saying it depends. I'm sorry for that. It always depends. It always depends. But yes, in many cases, that is the case. However, you should be aware that these things I think it's obvious that if you put persistent stuff in your container and you blow your container up, you're lost it. That's the whole thing that I wanted to mention.
Yeah, cool. So I'm a developer, and to be fair, I'm a lazy developer, and I rather do development work and less lifecycle management work. But lifecycle management is important to keep your application secure. Can you recommend some tooling to make that a little bit easier and perhaps more secure?
Yes. I can do a lot of things, but I won't go too much into tooling names. I would make sure that you automate as much as possible. And you can either, I did some things with my own tooling on the command line, but you can do these things like plugins in your IDE. We supply a plugin, of course, so that you can use that over there. It depends on how you love to work. You can use a Gradle plugin or a Maven plugin that helps you with every build and scans your stuff. You can plug it in your CI system, but, and that's my opinion, don't only do it in your CI system, because that's already quite late in your life cycle. And just like we want to have early feedback from your unit tests, I want to have early feedback on stuff I'm creating. So if I'm creating something, in the creation process, I will scan it multiple times, just like I do with my, when I alter code, I run my unit test like a couple of times to make sure that nothing breaks, right? And then at a certain point, I'm done with it. I probably throw it into my Git repository, and my CI system runs, and then it's fine. But during development, you should already be aware what you're pulling in. So having tests in place and having things in place like automation in your Gradle or Maven environment, or tooling in your IDE, just like you do with your unit test, is advisable.
Cool, great advice. And then Erik Heskes asks, would following the CIS benchmark security for Docker containers be helpful to chunk down and harden your Docker image?
Absolutely, absolutely. Like these guidelines are nobody. Let's put it like this: they put in these guidelines to make it worse, right? But it's, first of all, I don't think that a lot of people know about these guidelines. To be honest, I don't know them by heart. I have to look them up. I probably have read them once or twice. But these guidelines are there from a perspective from a CISO, so a security advisor board kind of thing level. A developer is not so much working on that pace. So if you want to be secure as a developer, you have to have at least the concept of what can I do. And as a developer, and yes, I'm a lazy developer as well, I can relate to that, Wouter. I don't want to do a lot of security. I want to build new awesome stuff with new frameworks. And if it works, I want to ship it. That's my state of mind. So if you do these easy things and have the easy tools in place that can help you out, like the automation I just said to you already keep away half of the bad guys. I won't say you're completely secure. And yes, from a security perspective, you should do a whole lot more. But we're a team, and I'm talking for here. I'm literally pointing to developers. So it's obviously a yes, but it depends.
It depends. Okay, with that though, I have one final question.
Absolutely.
So we're living now in this different world. Everything is remote. We do stuff via the teleconferencing, remote tools, online tools. So our way of working and interacting with our teams has changed. Do you have any general tips, tricks, recommendations to make remote work and working in this new environment a little bit more secure?
A little bit more secure. Remote working. So then we are going in more or less into the hey, new people came in. Interesting. Oh my God, what the fuck?
Woo! We did it!
This Zoom call has now been hacked.
What is this?
Why are there people in this Zoom from a country, a third world country called America?
Got to get out somehow, right?
Absolutely. You cannot fly in, so you're just breaking in. What's this?
Exactly.
We know you've been written JavaScript. We know.
Oh God, even my manager is here.
We know you've been writing JavaScript.
Yeah, I'm sorry. I'm sorry for that. I have a manager that forces me to do JavaScript as well.
Just following orders, huh?
I think he's on to us. Let's skip the mask because it's getting way too hot here.
Oh my God.
Yeah, I agree.
That was too warm. Well, hello, everybody. I know this is unexpected for probably most of you, but we wanted to pop in. Normally we make these sort of announcements like in person, but we can't. So the rest of us are here to announce that Brian has recently been selected as one of our newest Java champions. So congrats, Brian. It's well-deserved and a long time coming. So for those who don't know what a Java champion is or what the Java champions are, it's a program started by Sun back in the day to help kind of honor and promote people who have made vast contributions to the world of Java. And Brian is certainly one of those guys. One of the nicest people you'll ever meet if you've not had a chance to meet him in person. So congrats, Brian.
Does that mean that the bar for Java champions is now lower? Because I'm not considering myself at that level yet. But
well,
thank you.
I mean, it's a pandemic, so you know.
Okay, I get the pity vote.
Brian, you start with being a Java champion, and then you get promoted to being a JavaScript champion. Then there's like a Node.js champion. I'll walk you through this afterwards.
Yeah.
I champion all the things. If that makes me get more money, Liran, I will do it. I'm a Dutchman, right?
Sounds good. We'll talk about it afterwards.
Wow, this is kind of a surprise. You're breaking in like this. What the hell?
I've never Zoom bombed before, so we thought, let's have some fun.
Vince is still a small scope.
I
think
that's
that, me?
There's your name in the bottom.
Yeah, we should have changed it.
Well, guys, this is wow. Yeah. Is this recorded?
Yes.
Yes, it's live streamed, I think.
Also.
Yeah, it's on the YouTubes forever.
Oh my
We'll
god.
save it for blackmail material.
Luckily,
All right, so let's not keep Brian waiting on us any longer. Wouter, let's wrap up, and then we can talk further with Brian offline.
Yeah, so I want to thank all the viewers for attending. If you like, or at least please like and subscribe, it really helps us. Probably in a month or so we will host another meetup. But John, can you remind me on who is joining then?
Yes, but it's still a secret. So
It's
I'll
still a
remind you
secret.
right after we finish.
Okay, then follow us on Meetup, and then you'll see the pop-up notification. Thank you all. Have a great evening and stay safe.
Bye, everyone.
Bye.